All right, what we wanted to do is be able to, without the use of our graph, be able to accurately determine whether or not our tangent line was over or under approximating the value of the function. And we're going to do that with concavity. Spell it correctly, concavity. Why is that? Well, here, let me draw you some pictures. Because if your function is, say, concave down, and then I put myself a point of tangency, and then here's my tangent line, and this is, let's say this is our point A, that's right here, and here is our point B that we are going to approximate our function at. You can see that when this thing is concave down, that our tangent line here is over approximating the function. Right? That's one of the ways to define concave down, that the tangent line appears up above the function. Okay, so let me draw this in the opposite way. Let's say that we have our function which is concave up, and then we draw in our point of tangency and our tangent line. And then again, here is our point A, where we found our point of tangency. And then here is our, let's say, our point B that we're trying to approximate the function at. And you can see that the tangent line, whenever this thing is concave down, that the tangent line is down below, so this is going to under approximate. Scribble, scribble, scribble. Under approx the function. So how do I determine whether or not my function is concave up or concave down? I do that with the second derivative of the original function, not the tangent line. That would be silly. Okay, so let's get the derivative back here. And I am actually going to use this copy of the tangent line. You know what? I'm gonna get rid of the one that's right there. Come on, copy. Here we go. And paste. There we go. And now let's take its second derivative, shall we? So f double prime of x is equal to negative 1/4. What is with my fours today? X plus 3 to the, we subtract 1 from that, negative 3 halves. Right, and then also, oh, don't forget, times 1, the derivative of the interior. Let's rewrite this thing. Negative 1/4, and then this would be the square root of x plus 3 quantity cubed. Pretty sure. Okay, so now let's, do I want to evaluate my function at that particular point? Well, okay, I'll go ahead and do it. Let's just see what happens. If I evaluate my function at, what was it, 1? This should be equal to negative 1/4 times the square root of 1 plus 3 is 4. We're going to cube that. Let's see, 4, square root of 4 is 2. 2 cubed is 8, which makes this negative 1/32. And it's concave down at x is equal to 1. But guess what? That does not matter. That doesn't matter. Oh my gosh. Hopefully this is making an impression on you, because it is important. I don't care about the concavity at the point. Actually, I do, but I need to broaden it up just a little bit. I'm going to insert a little extra page here so I can draw you a further picture, shall I? All right, so we saw that it is concave down at the point of tangency, right? Okay, so if I were to draw my graph here, concave down, and then let's say that it comes back over here. All right, now then, I'm going to put my tangent line right up in here. Okay, and then let's say this is the point of tangency A, at which I just found the concavity, also the tangent line in order to do my approximation, right? And then let's say right over here is where I want to approximate that. Let's say that this value down here is B. Well, can you see why the concavity just right here around point A, it wasn't enough? And the reason why it wasn't is because this function changed its concavity and then came back up and it crossed through the tangent line. And now, even though very, very clearly around this point of tangency, it's over approximating the function, it's entirely possible that over here on this right-hand side, over around B, that it starts to under approximate the function. So what does that mean? This means that what you need to do instead is that you got to get yourself an interval. So right here, we want an interval that contains the function value you are trying to approximate. So if our function remains concave down past the point of tangency and also past the point we're trying to approximate it at, then we can be guaranteed that our tangent line is over approximating the function at that particular value. So let's re-examine, shall we, our second derivative here and see if we can make some sort of argument about it. F prime of x was equal to -1 over 4 square root of x plus 3 quantity squared. So you want to analyze this. You probably want to think of your original domain, and the original domain here is x has got to be greater than or equal to -3, I believe, right? Okay, so you're never going to stick anything in there outside of that range, or that domain, I should say. So think of those particular values. Whenever we stick something like that into the square root function, oh, wait a minute, that is supposed to be cubed. Anyway, the square root is going to return a positive number. Then you're going to cube that positive number and multiply it times +4. So no matter what, this denominator down here is always positive. This one is always positive. Okay, but we can't say the same thing about the numerator because it's being multiplied times -1. So I have negative divided by something that's always positive, no matter what. For the entire domain, we're going to say that f, this is not f prime, this should have been f double prime. Come on, you guys, pay attention. F double prime has got to be less than 0 for x is greater than or equal to 3, right? Or actually, you know what? I'm not even going to put 3 on there. Well, can I put 3 in there? No, because that's an endpoint, so I'm just going to say it's greater than 3. That makes more sense, okay? And that's important now that I have included, so this is all values greater than 3. Again, you're not paying attention. You're not paying attention. -3, there we go. This includes my point of tangency, and it also includes the point which we're trying to approximate it at, all the way through to, what the heck was this? 2 over here. So we can conclude from this that our function is concave down. So f of x is concave down on the interval from, -3 to infinity. So I can just say on x is greater than -3, and the tangent line over approximates the value of the function. And what I am writing right here is the kind of thing that you would want to write on an FRQ for justification as to whether or not Your tangent line is over or under approximating your function. Is that something that you will be required or expected to do? Absolutely.